lesson you will add and subtract radical expressions and multiply radical expressions. So when you have a like radical, so for example radical 2, and radical 2, you can combine them. So we think of it like with a variable, if I have 5 radical 2's plus 7, that would make 12. And then I subtract 6 radical 2, then that's a total of 6 radical 2. So you can just think of it like variables or like terms. As long as it is the same number in the radical, you can combine it. Another example here is that I have some radical 7's and I have some radical 11's. So I'm just going to rearrange so that I have the like radicals together. So it's 10 radical 7 plus 4 radical 7. And then I have plus 5 radical 11 minus 6 radical 11. So now I can combine the like radicals. I have 14 radical 7's, and then I just am subtracting 1 radical 11. So I can just leave it as minus radical 11. I don't have to put a 1 in front of it. So you try the example in your notes. Now what do we do when we have radicals that are not the same? Well, if you will notice here, all of these could possibly be simplified. So we're going to simplify first. So when I simplify radical 18, that's like radical 9, radical 2, so that's like 3 radical 2. So 2 times 3 would be 6 radical 2. Now radical 32 is like radical 16 times radical 2, which is 4 radical 2. So this is 2 times 4, so that's plus 8 radical 2. 72 is like radical 36 radical 2, which would be 6 radical 2. And now we have like terms. Now that it's been simplified, we have radical 2's that we can put together. So 6 plus 8, 14 plus 6 more, so this would be 20 radical 2. So you have to simplify first before you can combine. So you try the example in your notes. Now multiplication works a little bit differently. In multiplication, I'm going to have to multiply what's outside the radical, so 3 times 2 to get 6, and then I multiply what's inside the radical, 2 times 6 to get radical 12. Now this is not simplified because there is a perfect square factor inside here. It's radical 4, radical 3, which would be 2 radical 3. So I can take 6 times 2, which is 12, radical 3. Let's try another multiplication example. In this example, we're going to have to expand, if you remember distributive property. So outside I have 3 times 2, which is 6, radical 5 times radical 5, which is radical 25, plus 3 times 5, which is 15, and then radical 5 times radical 3, which is radical 15. Now this can be simplified into 5. The square root of 25 is 5. So this is 6 times 5, which is 30, plus 15 radical 15. There are no perfect square factors of 15, so this is simplified. Now I cannot combine the 30 with the 15 radical 15 because this is just the whole number 30. There's no radical 15 behind it. So therefore we're simplified. So you try the example in your notes. Now when we have a binomial times another binomial, if you remember how we FOIL, or if you wanted to use boxes, you could use boxes, and you could have 5 radical 2 minus radical 3, radical 5, and 4 radical 3, and you could solve it that way. I'm just going to use FOIL. So first term would be 5 radical 10. Outer, what I have here is 5 times 4 outside, so that would be 20, so that's plus 20. And then radical 2 times radical 3, which is radical 6. Inner, that's negative radical 15. And last, 4 times negative 1 is negative 4. Radical 3 times radical 3 is radical 9. Now we're going to see if we can simplify. 10 cannot be, 6 cannot be, 15 cannot be, 9 can be. That would be 3, so this is 4 times 3, which is 12. So it's 5 radical 10 plus 20 radical 6 minus radical 15 minus 12. And that would be your final answer. You are going to have to, when you use FOIL or boxes, just remember what we did with multiplying. Keep what's outside times what's outside, what's inside, what's times inside. Try the example in your notes.